Hello everybody. Today we're going to be presenting our science fair project. Our group is formed by Diego Gallardo, Andres Mejia, and me, David Lopez. And our project name is Combating Drought with a Low-Cost Biodegradable SAP Made Out of Orange Peels.
Well, our project is an analysis of the proposal for combating the drought caused in South Africa by using a SAP made out of orange peels. We found interest in this project because we hadn't seen an idea like this one being mentioned as an alternative for fighting against drought caused by global warming. It's pictured as an eco-friendly and profitable way of making an effective SAP. We decided to prove the effectivity of this proposal by analyzing the data provided by the people who originally made the experiment.
We posed ourselves a scientific question. The scientific question is as follows. Can the negative effects of drought be combated through the use of orange peels?
Now our hypothesis. If the orange peel functions correctly like a SAP, then it can be used as a natural and recyclable SAP that can be made from our homes because it yields the most moist soil and supports the greatest plant growth compared to the other SAPs.
The materials that we are going to use in this project are oranges, avocados, general lab equipment, soil, humidifier, a knife, oven, cooking pot, flowers, and water.
Our procedure is divided into two steps. The first step is calculating water retaining ability. 5 kilograms of starch base, pectin base, and acrylic base and 3 orange peel variables were placed into 6 separate glass beakers. 200 milliliters of distilled water was added to each beaker. Each beaker was left for 10 minutes. Now for the second part, monitoring soil moisture of plain topsoil. We start by preparing the soil. 7 planting containers were filled with 1 kilogram of topsoil. Each pot received a different sample or variable, 25 grams of starch sap, 25 grams of pectin sap, and 25 grams of acrylic sap served as the positive control group. 25 grams of orange peel powder, 25 grams of orange peel solution, and 25 grams of orange peel mixture served as the experimental group. And 1 planting container containing no sample served as the control. Each sample was mixed with the soil and saturated with 100 millimeters of water on day 0. No additional watering was performed during the experimental period, which lasted 21 days.
And also, the results are divided into. First, we have the water retaining ability of various reagents. It was observed that with application to the water absorption formula, the orange peel mixture displayed the strongest water absorbing abilities of 76.1%. The acrylic sap displayed a water absorbing ability of 74.7%, whilst the pectin, starch, orange peel powder, and orange peel solution saps fell under 70%. And for last one, we have the soil mixture measurements of plain topsoil. These results indicated that the 3 orange peel variables, acrylic sap, starch sap, and pectin sap, all had significantly greater soil moisture levels compared to the control after day 10. 21 days after the initial watering on day 0, the soil mixture is the pots containing the orange peel powder, orange peel mixture, starch sap, and acrylic sap remain at the moisture levels of 3.8 to 4.8. These moisture levels are also plant growth friendly. This experiment also indicates that there was no significant difference between the orange peel mixture and acrylic sap in soil water retention.
And we are going to end up with our conclusion. Analyzing results of 3 experiments that they spanned over 45 days that tested that the water absorption abilities result in soil moisture and growth of a produced plant given off by starch, pectin, and acrylic sap, and various other forms of orange peel variables, our hypothesis was proven correct. The results of the water retention test showed that the orange peel mixture can absorb 76.1% of water, which is significantly greater than the acrylic sap, starch, and pectin. The experiments also support our hypothesis as the orange peel mixture, when applied to soil, maintained the greatest average soil moisture and the Ocimum sanctum plant had the most flowers. The greatest height and healthiest appearance in the orange peel mixture treated soil. And we also have to say that the creation of a low-cost superabsorbent polymer is a possible and proven to be more effective than other alternatives. The orange peel mixture, which is the one we made, is made out of waste products found in used manufacturing industry. And the only resources involved in the creation of this mixture were electricity and time. No special equipment nor materials required. Commercially used acrylic sap retailed for around $2,000 to $3,000 per metric ton, whereas the orange peel mixture could retail at $30 to $60 per metric ton. Possible sources of error in the experiment process could be fluctuations in temperature and humidity.
That would be it for our experiment. If you have any questions, we are free and open to answer them.